Hey folks, how we doing? We're on page 90 and we're looking at number 9. Alright, so in this situation they're giving us a probability tree and they're telling us the probability of answering the question correctly is 0.7, wrong is 0.1, and asking for help is 0.2. That's all filled in. Evidently, if we ask the audience, there's a 0.95 chance of getting it right, so there's a 0.05 chance of getting it wrong. Alright, so all the information they gave us is in there. They say show the probability that answering the first question correctly is 0.89. So we need to look at all the ways that you can answer the first question correctly. So the first way is Peter just answers it correctly. Alright, so that's pretty clear. That's going to be 0.7. Now the other way is if he asks for help, which is going to be 0.2, and then the audience gets it right by 0.95. So if I take 0.7 and add 0.2 times 0.95, I represent both those situations where he gets the first question right. And that'll be 0.89. And that is what they said, so we're good. Now, second part, they've added some more information. Make sure you read through it. Now it's good. If he asks for help a second time, he's going to be talking to a friend. Find the probability that both are answered correctly if he does it twice. So again, we have to look at all the possibilities. So let's add some branches to our tree. If he answers the first question correct, then he goes to the second one. He could get it correct, get it wrong, or he could ask for help. Those are his choices. If he asks for help, well, then the audience could get it correct, or the audience could get it wrong. Now, when we go down below, if he answers the question wrong the first time, well, everything just stops. So we don't worry about that. But if he asks for help the first time, then gets it right, he can go ahead and again have three options. One, getting it correct, getting it wrong, or asking for help. If he asks for help, now he's asking a friend. And so now there's a 0.65 chance of getting it correct. Alright, so let's fill in all the probabilities. Getting correct is 0.7, getting it wrong is 0.1, and help is 0.2. And let's see, then audience getting it correct, and then getting it correct. 0.7 is getting it correct, 0.1, and then asking for help is again 0.2. But now my friend getting it correct is 0.65. So getting it wrong is 0.35. Alright, so find the probability the first two questions are correct. We need to look at all the situations where he gets the first two questions correct. So let's see. The first possible situation is where he just gets the first one correct and the second one correct on his own. That's 0.7 times 0.7. Alright, now the next way this can happen is if he gets the first one correct and then he asks for help, which is 0.2, and then the audience gets it correct. That's 0.95. So that's going to be 0.7 times 0.2 times 0.95. Alright, how else could this happen? Well, you could ask for help the first time, and then the audience could get it right, and then he could get it correct himself on the second question. So that's going to be 0.2, and then 0.95, and then 0.7, because the second question he gets right on his own. And then there's another possibility where he asks for help and gets it right, but then he asks for help again and his friend gets it right. So that's going to be 0.2, and then 0.95, and then 0.2, and then his friend getting it correct will be 0.65. So I've got to take all these four different ways he could get the first two questions right, and then I've got to add them together. So really, at this point, it just becomes multiplication and addition. And after we get these all spelled out, we're going to find out that together there is a 0.7807 chance of getting the first two questions correct. Now in part 3, that's a given question. So given the first two questions were both correct, find the probability that Peter asks audience. Alright, so given. That's a key word here. We know we're going to have to use the conditional probability formula. And let's make sure we get this written down correctly. So we're looking for the probability that he asks the audience, given that he gets the first two questions correct. And the way we find this is that we're going to find the probability of asking the audience and getting the first two questions correct. And then we're going to divide by the probability of getting the first two questions correct. Now you'll notice in the prior part 2, we already answered the question about getting the first two questions correct. So our denominator is going to be 0.807. So now we've got to find the different situations where we ask the audience and gets the first two correct. Well, that's going to be down here 0.2, and then he gets that right, and then 0.7. So the first one is asking for help and the audience getting it correct, and then him getting it correct himself. So that's 0.2 times 0.95 times 0.7. Now, the other way this could happen is he could ask for help, the audience can get it correct, and then he could ask for help from a friend, and the friend could get it correct. So that's going to be 0.2, 0.95, 0.2, and then 0.65. Now, is there any other ways that we could get the first question correct on our own and then ask for help? So that's me getting it correct and then asking for help and then the audience getting it correct. So that's going to be 0.7 times 0.2 times 0.95. So those are 3 ways, and in fact the only 3 ways in our scenario where he could get the first two questions correct and have asked the audience. So all I got to do now is multiply this stuff together, divide, and you get 0.372. That's the probability of him asking the audience and given the first two questions are correct. All right, thanks for watching. Hope that helped.